Yeah, okay, so there's not really any rest here. We're going for the full 4 hours. And I want to kind of show you the other extreme to solve this problem. I mean, we have it on video just solving it normally, I think, somewhere, so we can send you that at some point. But I want to really show you something that's not in the solutions anywhere. Yes. But I need to give you a bit of prerequisites. So this stuff you're not really expected to know, but this is kind of on the grounds of what I was talking about before when I was doing the advanced techniques. So the stuff that I haven't showed you before, I'll show you right now. And the stuff that I have showed you before, I'll just quickly review it as I do it. Okay? So this is barycentric coordinates. If you solve a problem using this, it's affectionately known as Bary Bash, which is, it sounds really Australian. Okay, so the two things I want you to show. So this is a prerequisite thing. It's actually not that hard if you can get around the big word, determinant. So what happens is you have a determinant of a 2 by 2 grid of numbers. So it'd be like 3, 2, 1, 5. You always get one number, and it's equal to the product of the diagonal entries minus the product of the off-diagonal entries. Okay, so that's the definition for a 2 by 2 determinant. If you have a 3 by 3 determinant, like 1, 2, 3, 4, 5, 6, 7, 8, 9. The formula for this, so you can choose any row or column and do this. Okay, so let's just for simplicity pick the first row. So what you do is you take the entries of the first row, so it's 1, -2, and 3. So you alternate the signs, and you times them by the 2 by 2 determinants. The 2 by 2 that you get if you deleted the row and column that the number was on. So here it'd be 5, 6, 8, 9. Here it would be 4, 6, 7, 9. Maybe someone can tell me what this should be here. So you don't have to think there's any significance behind this at the moment right now. It's just really a nice way to write down a formula. Okay. Okay, 4, 5, 7, 8. So you see how George got that? He deleted the 3 and the row and column, so that's left with this 4, 5, 7, 8. Okay. And then you can use the above formula here to calculate a number. Yes? Do you understand what that means? So it doesn't mean anything except for a definition right now, okay? So I'm not asking you to understand anything, I'm just telling you how to do something, okay? I'm defining a process. So whenever I write 9 numbers in a grid like this and put vertical lines around them, this is the formula to get a number, okay? And the reason I'm introducing this is because this gives me a convenient way to express so the area formula in barycentric coordinates. So the area of a triangle is equal to the area of the reference triangle ABC times the determinant of the coordinates of P, Q, and R. So Px, Py, Pz, Qx, Qy, Qz, Rx, Ry, Rz. So if that looks really weird right now, maybe I'll give you a bit of a practice run. It doesn't have to be positive, but I think it ends up being positive if you write it in the right order. Maybe clockwise or anti-clockwise. But otherwise, it's just going to be the negative of the answer. Okay? So the most basic example is when you have just your reference triangle. The coordinates are 1, 0, 0, 0, 1, 0, 0, 0, 1. Can you see how this formula works for this reference triangle? It's barycentric coordinates. They basically mean where your point is if it's the center of mass of certain weights at vertices of the triangle. So if you put 0 weights at B and C and put something at A, then the center of mass will be at A. That's why A is 1, 0, 0. Yeah. So if you look at the formula applied to this, right? So the formula applied to this just says the triangle area of triangle ABC. So maybe I'll put this as area is equal to the area of triangle ABC times the determinant of 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, can someone other than George tell me what this determinant value is? Though it should be obvious that for this formula to work, it has to be 1, right? Yeah, so if we were doing this as before, if we pick like this row, right, it'd be 1 times something plus 0, or minus 0, plus 0, but that'll all be 0, right? And then it'll just be 1 times 1, 0, 0, 1. And 1 times 1, 0, 0, 1 is just, it's 1 times 1 plus minus 0 times 0, right? So that's 1. So the area of the reference triangle is always 1. That's why you got to times it by a factor of the area of the triangle to make it all work out, right? Another example. Oh, how about this? If I took the midpoints, so if I took the midpoints here, right? I got so C is 0 here, this would be like half, half, 0. And this would be like half, 0, half. And this would be like 0, half, half. Okay. So what would be the area of this medial triangle, yeah? So we actually know it's a quarter. I think we know it should be a quarter of the whole thing, right? So what does the area formula give us? So let's call it like DEF. So area DEF equals area ABC times the determinant of so maybe DEF would do. D is the bottom one. E is that one. If it comes out negative, I'm sure it's just the other way. The sign doesn't really matter, but it could come out negative if you remember it the wrong way. So 0, half, half. Half, 0, half, and half, half, 0. That makes sense? So from kind of our geometry knowledge, I think we expect this to be a quarter. Because the triangles are all it's similar, but all lengths are halved. So we expect this determinant to be a quarter. So maybe can you do a calculation? I think if it worked out before, the area shouldn't be 0. So you should put the vertices either always clockwise or anti-clockwise, but the difference will be at most a minus sign. So yeah, this is kind of a little bit beyond us, but I kind of want to show you just sort of how far doing this problem can be stretched. Oh, Haibing's here.
So
Yeah, so everyone, Haibing. Haibing's the person whose solution I showed you just before, and just came back from representing Australia. Got a silver medal, and this was his first AIMO basically, where he got a prize. Okay. Alright, so can we check that this is a quarter? So I think he was in year 9 and he got like either 31 or 2 or something like this. Alright, so how do we work out this determinant? We can pick a row or column, okay? So do you want to mix it up or do you want to just repeat? So maybe just repeat the first row, okay? So it's 0 minus a half plus a half, yeah? And then the values here 0, 0, half, 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 0. Can someone tell me what goes here? So when I say yeah, so obviously 0 times anything is just 0. Half times 0 is just, so this is minus a half, and it's 0 minus a half times a half plus a half, half times a half minus 0. Yeah, so this is a quarter. Yeah, yeah. So the formula checks out for that, but we're not going to prove the formula, we're just going to use it. Okay. Yeah, so right now we're just assuming this formula, okay? We're not proving it. So I've just told you enough to use this formula, but so you know, the nicest way to actually do this for your age in the exam is this fake solve method that Hai Bing did in 2018. But you might come to appreciate this other method in time. Okay, so let's look at this question again, okay? So this is the diagram. So we're told that P divides the ratio, AC in the ratio 1 is to 3, right? And Q is a midpoint, and we don't know where R is, yeah? But we know that the area BRQ is half the area PQR, right? So maybe people can get a bit more involved in this. Yeah, I guess if we run out of time, we can continue the 9 and 10 on Saturday, but we'll see. This won't go for that long. So, all right, what's an obvious thing to do on this diagram, people? So we're told that we're looking for 2 alpha, and the overall area is 300. Yeah.
We use Bary.
Yeah. So if we're gonna do barycentric coordinates, so an obvious thing to do would be let A be 1, 0, 0. Yeah.
B 0 1 0 C 0 0 1.
And C therefore 0, 0, 1, right?
And then Q is 0 half.
Yeah, so we know what Q is, yeah? So we know what Q is the midpoint we did before, is the A part is 0, and it's halfway between B and C. So Q is where the center of mass would be if you put equal weights on B and C and no weight at A, right? So if you put no weight at A, then obviously Q will be on the line BC, and depending on what values you put on B and C, Q will be closer to B or closer to C, right? So Q will be halfway if it's equal values at B and C. Yep.
Would P be 3/4, 0, 1/4?
So P, oh yeah, so you're doing quarters, yeah, so okay, so let's figure out what P should be, right? P should definitely have nothing in the B component. And you said it was 3/4 at A, 1/4 here. So if you put 3 times as much weight at A, it should be closer to A, right? Okay. And what else? So we don't know where R is necessarily, but we do know R has a 0 in the C component. Okay, so we can leave this as a variable maybe. So we could have it like um we could have R and 1 minus R. This will be R and 1 minus R. We don't do that. It's just the ratio is R to 1 minus R. Alright, can people see what to do next? Yeah, so Max is saying use the area formula, right? So let's have a look how the area formula works. So maybe delete the question now. I have the area formula. So this is P. Oh, I just erased stuff. Yeah. So triangle BRQ, yeah? sorry, triangle, yeah, it's triangle BRQ and triangle PRQ. And so BRQ, I think it's always easier to do stuff with, we'll see. So the area of the triangle is ABC. We can put that in as 300 later or now, times 0, 1, 0. And Q is 0, half, half. Yeah, that's a good question. You can think about it, right? You have two equations, right? And one basically two unknowns, right? Alpha and R. So that's one of the equations. The other equation is PQR equals, so ABC again. So you know that's 300, right? So it's not an issue. And P is 3/4, 0, 1/4. Q is 0, half, half. And R is R 1 minus R 0. Okay, so can you see we've basically, this problem has been converted into a problem of pure technique. Okay. So can we have people, let's see, help figure out what this, we'll do this one in green and maybe this one in purple. How about that? Oh, it actually works. Epic. Excellent. So that gives me some confidence. So if we took the first row here, maybe it'd be 0, minus 1, 0. So we just need the minus 1. And the minus 1 times basically R half 0, 0. Okay. And this thing here, we pick the top row again. And we get 3/4 outside of something minus 0, which we just ignore the minus 0, plus a quarter outside of something. So this something is half 0, 1 minus r. This thing here is, oh, thanks, 0, half r, 1 minus r. Yep. Okay, good. I should have done it in purple, sorry. Maybe I'll write it in purple above. So I'll write, we'll kind of keep track of these things in the same page, hopefully. Write it up here. So this thing is simply just r times a half, right? And this other thing here is, so half times 0 is 0. And so it'll be minus half times 1 minus r. And the other thing will be plus a quarter times half r, but minus. So it'll be minus a quarter times r on 2. And if you look at the equations, they're both times by 300. So we can just cancel the 300s. And but we know that one of them is double the other one, right? PQR is twice BRQ. So this thing here should equal 2 times this thing here, yeah? So what does that give you? It gives you minus r equals, oh, you can take all the minus signs away, plus r equals sort of 3 on 4 times 2, 1 minus r, plus r on 4 times 2. And then, yeah, you can do lots of things here, right? So maybe 8 is not too scary, we just do 8r equals 3 minus 3r plus r. And then you get, wait a minute. No, yes, 10r equals 3. Yep. And what are we after? We're after uh, hmm, something. Oh yeah, it should be plus. Hold on, so now people are writing over the top, so it's hard to read. Did something go wrong? Well, let's see. How do I know something went wrong? Actually, maybe something didn't go wrong, yeah? Maybe it went okay. Let's have a look. So we have R equals 10, 3 on 10. Is that what people said? Okay, and then the area is equal to 2 times is equal to R basically, right? It's 2 times R on 2. But remember R is the area once you divide it by 300, right? So you gotta times this. So it's 300 R is what you're after, actually. So we still get 90. Is that what you did, Johnson? Okay, great. Yeah, I guess I was worried that something went wrong because R was like a fraction, but once you times it by 300, it's fine. Yeah, I mean, we don't really expect you to Bary bash it. So I think if you get a chance in the exam, I think doing it Haibing's way is best. Well, this is kind of like a preview of the future. I mean, think about how this method actually works. If you knew the formula, you would get the problem in its general form. So this would be a proof of the general case, and it's completely routine, okay? Another reason why you wouldn't be expected to know this, I guess not necessarily the markers even know Bary Bash that well, but I think it's well known enough that they could probably look it up to mark your answer. Yeah. Is there any comments? Um, does Haibing still remember his experience of 2018 AIMO?
It's been a while. If I guess it's like if you find a question that's bashy and annoying, skip it.
I think I remember in this year the question. Oh, maybe this is for later, but I remember you doing the investigation instead of the question 10.
Uh,
Was that this year?
Hang on. Which question did I get wrong? It was
No, I don't think you got any questions wrong. Like when you get
uh
31,
it was I got the question I got question like 5 or something. It was the factorial last digit in the factorial or something. Oh my
oh,
that one, yeah.
oh yeah, we said that was like only 250 people got that out of the 2000.
Yeah, one of those wasn't me.
Yeah,
Or all of them weren't me.
but you only lost maybe 1 mark for it, or did you lose more than 1 mark?
One probably like one, I think, or maybe max two.
Yeah,
Just write some working, you'll get some marks.
yeah. This working thing is beyond some people, such as Leon. Oh, actually, wait. I think question 5, like 400 people got it. No, that was question 4. Sorry.
Yeah.
Yeah, it was actually a fifth of people that got it. So yeah, it was like guessing an even number. Yeah, but this triangle question only 200 less people got this one, and Haibing was one of them using this solution. I think he literally used this H as well.
Yeah, probably. That seems like a good number to use. Yeah.
Yeah. Okay, so I'm gonna hand this over. Yeah. So what do you think of the Bary bash, Haibing?
Uh, it's like I guess for this one, it's probably a good way to like get used to it.
Yeah, good way to learn it, right? Not
Yeah,
necessarily a good way to try it in the exam. Don't try this in the exam.
yeah. These are the one like practicing stuff on easier questions is a good way to like get good at like that one skill. Like
Yeah.
when you're practicing, you don't necessarily need to make it easy for yourself.
Yeah, like if you know it's gonna be easy, you could use a different method that you're not as familiar with, like complex bash or Bary bash, to learn the method a bit better.
Like for example, like the way I solved it there, right? My solution there, you don't need to like, yeah, of course you could do that. You could do this question that way and just be done with it. But like you're not really getting like the most out of doing it that way. Like in your exam, you could do it that way. So like you can, it's like if you do this, it's kind of like being lazy, right? And then being lazy is fine if you can like getting results by being lazy is like not a bad thing, but it's like you can practice being lazy, but you shouldn't like practice lazily.
Yeah, so once you have the time to review it, you might want to do this without using either method, right? To do it the general case using geometry, and I think that's what Haibing did after the exam was over, right?
Maybe like I'm not sure. Maybe like sometime after, but yeah.
Yeah, I have it recorded, so certainly. Um, so I remember you had to present it to the year eights at the time. Yeah, maybe not immediately after, but eventually, right? Or maybe even
Yeah,
preparing for the 2019.
yeah, that would probably be it.
Yeah, so just because like he kind of like subverted the question during the exam, it doesn't mean that um the question wouldn't be an interesting question to do outside of the exam in its complete generality, right? And so I only presented like two really extreme ways to do this question, and the sort of more normal ways, I guess it has been recorded and might even be in the official solutions as well. So, but these two solutions are definitely not going to be in the official solutions. Yeah.